Welcome to the dOrg hot seat. One more episode, this time with Layer and specifically talking about waves. We're going to see what that is. At dOrg, we started doing this podcast to get you connected with the project that are building at the edge of Web3 technology. And we can help you build this technology through our services, which are milestone-based collaborations, team extensions, protocol partnerships, contract to hire, and whatever you need in terms of development. So let's get to the episode of today. Reece, welcome. Tell us a little bit more about your background.
Yeah, so I joined into crypto in 2021, came in actually building up Minecraft servers to connect them over to blockchain environments, was the first one to do that in a decentralized way. We got shut down by Microsoft, and so since then, I've been diving in deeper on the protocol sides and working on developer experience tooling over the past many years. The biggest problem that we've come up with constantly is that it's actually really hard to continue to build applications. We have all these ideas, but the infrastructure is so specific to each one, it just doesn't make sense. And so then found Waves and was like, this is exactly what we needed from a developer experience tooling perspective, and decided to take that on as a role, helping to architect it in terms of the tooling side, and how do we really get this to be the best product to build out, not only for our own internal purposes, but also for others. And so working with the team on improving it across the stack, finding those problem areas that we're seeing with key integration partners, and then resolving that is what my day-to-day looks like.
Right on. Okay, so tell us a little bit more. So what is the relationship between Layer and Waves? And yeah.
Layer is just the parent company. Waves is the core product that we're doing because we expect to launch multiple different projects internally for ourselves. That's what we built Waves for. We needed, hey, we have this Waves product here, but it's kind of morphed into this thing where even though we built it for ourselves, it really makes sense for us to give that to someone else and give this to other teams that are all running into the same problems that we ran into many years ago and continue to run into today. And so we've also now open sourced different parts of it to give it to other teams and work with them because we want to make their lives as simple as possible as we have made ours.
Right on. So basically you were building, and then you found that you needed something, and you built this something, and now you're putting this something out there for other developers that might need this.
Exactly.
Let's get into the specifics of it. Tell us more. What exactly is Waves, and what can you use it for right now?
Yes, if you're a technical person, the way that I describe it is it's like Kafka for blockchain. If you're not technical, what that means is that I can watch for something to happen. It can be kind of whatever you can think through programmatically. Watch from somewhere, do something with it, submit it to anywhere. That could be on a blockchain, that could be off of a blockchain. So you could watch a Web2 API like a Twitter endpoint, do something with that every time a new tweet is posted. And then after that happens, submit that either on chain to verifiably prove over time, here's their tweet log, or save that to a personalized Web2 database. So it's up to you to decide, do you actually want the crypto aspect? Do you want it just for the verifiability, or do you actually want to submit it using crypto as your database? It allows you to pick and choose depending on where you need. While we do support watching Web2 events, you can also watch Web3 events. That's really what we personally needed it for. Hey, whenever a transaction happens on chain A, do something on chain B. Submit it to different areas, and we can mirror that kind of information as well. So there's a lot of different ways you can mix and match this. But at the end of the day, the main focus was Web3 to Web3. It just extends over to Web2 and Web2 as well.
All right, so observability, verifiability, and then actionability, and you can mix and match whatever you need. So basically, you have some sort of oracle, right? That could it's not necessarily a blockchain oracle, but it could act as an oracle. Let's dive deep into the observability part of it. How does it work? What technologies are you using? And is there any limitations to what you can observe?
So right now we have it as being able to follow any EVM chain. We call these input triggers. So this is the observability layer. We can follow any EVM chain, L1 or L2s. It's just following the blocks. It searches for certain event hashes, which are like the functions that a user would run against a certain contract, for example, like Uniswap. Whenever you execute this Uniswap pool, we're going to be able to follow that, and we can execute on that. Other chains are also Cosmos. So any Cosmos chain with the WASM smart contract layer, Ethan Fry, one of the actual co-founders of Wave, was the one that invented this. So being able to support WASM as well and having those be interoperable. And then anything else that you want to build on top of that can be used like with cron jobs. So maybe every 1 second, we go check for some data from an endpoint, or every block go check from some data from an endpoint. And then in the future, this currently isn't in main yet for users to use, but we'll also have it where you can extend and write your own custom logic for how you want to follow. For example, specifically a Twitter API, following a WebSocket, being able to pull. So as data streams in, then you can do something with that. It's really up to you, but in the worst case, the cron job system usually works for most users. Just check what the difference is between the last post and current post. Now do something with that.
Right on. So once we observe something, then how do we record it in a way that people can trust that this has actually happened?
Yes. So the biggest case here is how much security do you need? For some applications, maybe you only need 2 to 3 different providers. We're going to help bring you those providers. These are reputable people within the ecosystem, operators, validators that you'll see across the board. So we'll have a group of those. You can also run them yourself. If you want to do proof of authority, you can do it between you and your friends for some action that is taking place. So you get to mix and match there. Once you have your set of, say, at minimum 3 for most use cases, if there's going to be financial ties to it, if you want something more, you can go up to hundreds, if not possibly even thousands of these operators. They're all going to run the same software. How this works is that you're going to build a component locally that is like your actual execution logic. So this is going to be written in Go or Python or TypeScript or Rust. So you can choose like a language that fits your case. We'll also have more languages in the future, like the C, C++, for those that are more on the game dev side. But you're going to write this, and this is going to then be uploaded to a registry, and we're going to set this to be used within a service config. So there's a config that's like, what do I need to watch? Where do I need to submit information to? What environment variables do I need? All of the operations that a DevOps person needs. What's going to happen is they're going to follow that, and they're going to register and opt in and say, hey, I am willing to validate this service. So every person that wants to be part of this service is going to validate that. Then they're going to begin watching for these events. So every single instance that is following this registered service is going to go watch that EVM chain or that cron ticker or whatever the case may be. So now you have multiple different parties verifying and watching for the same data source. That doesn't mean it's always from the same data source. That just means that they're watching from a data source to get some output, and then it'll be up to them to then submit that, and you'll be able to see who submitted that data. And do you actually trust that? Maybe only 3 of 10 people submitted it. You can't really trust that yet. So it's up to the application developer to tweak that. What's the trust and the threat model that we want here? But it ultimately depends on your application. That was a lot of information.
No, that was good. There's a couple of questions that I have though. You mentioned the operators are running these logic that can be written in whatever language or whatever it is. Does this mean that there is, depending on what you're building, you also have to build a node, maybe according to your specifications, your protocol specifications, but each node will be, so if for my Oracle, it will be a different node than for your automation tool, on-chain automation tool, or it will be the same node that will be, and it will have these sort of modules of arbitrary code that you can decide to execute.
Think of more like modules. There are some edge cases, for example, AI compute. You absolutely need a GPU. Technically, you don't have to, but if you want reasonable compute times, having GPU, we actually have a demo using 3 different GPUs up in AWS that we're running as our own proof of authority that is using a deterministic model to then execute some logic, say that up to IPFS on behalf of a user's request. So for something like AI compute, you do kind of need your own hardware for this. But for most use cases that are just using networking, storage, CPU, compute, RAM, you're able to just continue to pile on services within the same machine. Just for reference, WAVS is super lightweight. We're talking about like 1 GB of like RAM is like the absolute, minimum that you need to run this in like 0.1 CPU. So super lightweight. And I think on our rough testing, you can save about 10,000 services. So that could be like 10,000 modules of this code that is all registered on one machine. Super lightweight. And events only happen when they fire. So it could be that if none of your contracts are executing, then you're not actually using any compute. So it's like a serverless based function, just now brought over to the Web3 side.
Right. So basically, yes. So the WAVS module or the WAVS node is one, this piece of software that you're running. And yes, if you want to run a specific module, you might also need specific piece on that hardware that runs this software. But basically, we don't need a different node for your AI application. And when I say node, I mean like software, like a client a node. We don't need one for your use case and for my game and for whatever it is. It just there are modules within the same
Exactly.
Piece. Yes.
Exactly.
Okay. Excellent. Cool. How do you sort of opt in or out of such modules?
Now our flow is entirely on EigenLayer. We're of course looking to expand into the future into like even like non crypto native solutions. So right now you're going to deposit some funds onto EigenLayer and create an operator. And this is going to just set you up. It's similar to validators in Cosmos. You need some way to create it to verify you are who you are and put a little bit of economic security behind it to prove that you are actually an actor in this space. Then you're able to take it's called a service manager. We provide you all of the tooling to set up all of this, so we abstract a lot of it for you. But you're basically given an address that says this is the endpoint to your application. This is going to be in Solidity or in WASM or wherever you decide to deploy. And then you're going to take that address and you're going to say to EigenLayer, register me on this AVS. And it's going to do all of that backend calculations to get you into them. Hey, if you're down, you're going to miss blocks. You're going to, possibly get slashed in the future. So you're going to just opt into this specific service. Before you opt into that service, you can query. There is a endpoint that is get service URI, which is an IPFS link. You can go view that on IPFS and you're given this long JSON of what are you watching for? What components are you expected to be executing? All of that information is public and it's all always saved on the blockchain. You can go see those components and where they live on the wa.dev website or on some other registry like GHCR. You're able to then go look at that, see, hey, do I actually want to run this? And if it's open source, your operator may decide to reduce my risk. I actually don't want to run the Rust component that they're using because of supply chain attacks. I can write my own version in Go now and build it up to the same WASM binary. And now I can use that instead of the Rust component there. So there's some things that operators can decide to reduce their risk. Then they can pull that in. They've registered onto this. They're expected to begin, and WAVS will automatically pick up, hey, you've registered for this, and it's going to grab in all of that data and like update your services locally within the module runtime, and then begin executing on that as events come in.
I can't believe we took so long to talk about the restaking part of it, right? I feel like it's kind of like what we were. It's kind of like the promise that we heard with the initial idea of restaking, that you can basically secure anything, and it's basically security as a service. You can pick this, and you're actually using it for this. You're using it as if you could be using anything else. You could have built your own system, but you're just plugging into the EigenLayer system because they have built it already, and it uses Ethereum, which is a pretty solid way of securing whatever networks you're doing. So yeah, very, very cool. Have we missed something on the sort of like the last bit, the actionability? Is this part of also the code, or the code that executes on the operator? Is that a second part?
Yeah. So once you execute it, you've followed some logic. You're now doing something with that logic. Finally, it's time to like actually do something with that, either putting that somewhere or just kind of forgetting it. So there's a couple different options. Number one, you could say, hey, the compute didn't actually do enough. For some reason, there wasn't actually enough that we needed to do something with it. We can just return none and just be like, hey, don't do anything at all. Then the next option could be save this up to a database or some web 2. This would be in your execution side for submitting it. You could decide submit this to somewhere that is not really native to what WAVS is, but we can do something with that. So a good example, the best example is really a database or to a file. So just say this is like a temporary cache. Maybe we do something later with it. Maybe we don't. Maybe we want to do an endpoint. We actually want to like post to Twitter or something like that. So you could have an operator set that like controls keys, but is then able to control a Twitter account to submit transactions here. That's part of execution, but really it's submission. We're just kind of bundling them. And then if you want to submit it to a blockchain itself, like an Ethereum L1, L2, or Cosmos chain, you can actually return back the raw bytes that would then be submitted on behalf of the aggregator to the chain itself to then save that data over time. You can find this in the WAVS Foundry template example, where we show this in multiple different languages. And then we also showcase like how it's submitted, how to grab that data, what that looks like as it increments over time. And then in the near future, we're going to have submitting to like a Postgres SQL example as well.
So you could be submitting transactions, you could be submitting basically whatever.
You can submit any kind of arbitrary data that you want or transactions themselves. It's up to you in your application. What do you need? And that's why our saying is like you watch from anywhere, do anything with it, and then submit it to anywhere. It's really up to you to decide. We're just giving you that base info layer to do that.
Excellent. Cool. Let's dig a little bit deeper on the technologies that you've decided to use for this. This is a technical podcast, so don't be afraid of saying why you choose one technology over another.
Yeah, so on the back end, we're using WASM-time, which is a WASM runtime that allows for us to do the multi-language support here in a very lightweight way. The reason why we went with WASM is that the creator of Docker himself said that if WASM existed, he wouldn't have created Docker. It's super lightweight. We're talking about like millisecond like start times, and we can easily shut it down too. This is much more difficult than other solutions that use like entire Linux VMs. With this, you probably need, at minimum 2 vCores of CPU. You're going to need like 8 gigabytes of RAM. There's an entire operating system there, so you're probably looking at, at minimum 20 gigabytes, more than likely 50 to 80 gigabytes of space. That doesn't scale as you hit 3 applications. And so we need a solution that can scale. Docker kind of works, but there's its problems with like compose and like, hey, a container crashes out. How do you restart it? How do you like actually interface with containers over multiple languages? We would have to write up some really complex logic. And the biggest benefit of WASM is being able to use the WASI extension, which is WASM System Interfaces built by the Bytecode Alliance. What this allows for is us to write these generalized files. If you're coming from a like Go background, you're used to like protobufs. Ours is a WIT file, which is a like rough example of kind of what the interfaces are. And then we're going to give that to users, and they can write in any language against those interfaces. If you run some tool similar to what you would do with Solidity to say, hey, convert my Solidity types into Go or Rust or whatever, it's the same case, but now for WASM. Once you get those tools, though, the benefit is that if you don't like how we implemented our interface, maybe you needed some extra function, you can actually override our interface in your language, and then we could decide to actually use yours. So right now, because we're Rust maxis, all of us get to like rewrite our Rust code of the interfaces. We satisfy how to do things like network calls or writing to the file system. But if you think you have a better way that you can do that, you can actually go write yours in Go or TypeScript or whatever, depending on what your needs are there. And then we could decide, hey, we actually really like your implementation for that. We're going to use your function instead of ours. So we have a multi-language support as like a base library that anyone can then extend, and then others can do that. And that's super powerful, both on the low level, as well as allowing you to write in any language there. That's a huge uplift that WASI allows for us to do.
Yeah, for sure. We had a spin-off out of dOrg of another company that started a project called Polywrap, which was WASM-based as well. That was more targeted on Web3 dependencies and doing them self-contained on some WASM-like modules, and it was pretty cool. It was pretty cool. So we love WASM here. Let's talk about incentives. So how is the incentive layer built? Of course, on top of EigenLayer, but can you run us a little bit more? Like, what can operators expect to earn? How, in what token? How does this work?
Yeah, so the main reason we actually built Waves was for building novel incentive mechanisms. Like it's really good at that. Being able to watch from multiple data sources, as I mentioned earlier, like a Uniswap pool or something along those lines, to over time be able to build up these like point systems in a provable way. And watching, hey, Twitter engagement, did the person actually post this when they said that they did? And being able to watch all that. So we have all these data sources we can grab from, whether that be prove this person is real based off of a bunch of different accounts and areas and like the length of data with like an archive node, like did they just start for this or were they actually interacting before? Being able to build that up, making all of that open source, we can now execute and build like basically public models of incentives that we want to give these different people. And then over time with Waves, because we have this constant being able to watch, execute, what we can do is have a like payment of flows over time. Where as you continue to be within the bounds of what the application wants, we can give you a little bit of tokens now. And so we can drip over time as you're compliant. And as soon as you fall out of compliance, all of the nodes can like agree that you did fall out of compliance within the bounds set, and then now you no longer receive funds. So it allows for these things that like have never been really possible in crypto, especially at such a scale of both Web3 and Web2 from different environments. And being able to pull all that together, Waves allows for that. Once your application has a reason to do that, you built some protocol that people are using, it's up to you to decide how you want to give rewards back to either the restakers themselves or the operators. And so a lot that we've been discussing with is number one, fees of your application, standard, hey, just transfer some of that over. But then also you can build these KPI based incentives where maybe you have a pool of tokens. And then from here, you can send certain, depending on the environment, the different operators could vote what do they actually value in the network or the developer of the application itself. Maybe if you're more if you're more geolocated, then great, we're going to give you a higher amount because you're less risk to the network. It actually helps improve it. If you have faster hardware, maybe we're going to help pay for that. If you're willing to work into this, so we can build both a standard flow of here's a share of revenue, as well as here's some incentives for doing things better that are on behalf of the network. And here we can do this flow-based funding to you for that.
Did you build this, or you're leveraging EigenLayer on top of that?
So EigenLayer is just the security layer. We're building everything else on top of that. Waves is handling all of the incentives. That's up to you to build as the application developer.
So, give us some examples. What has been built so far with Waves, and what do you think it can be built? What's the wildest idea that you'd like someone to build on Wave?
Yeah, so we have a couple of projects internally that we're building. I can't share one of them, which is honestly the most exciting one, because we were in Berlin together, and over the course of 3 days, we built this like entire system that would normally take a team of 10 to 15, a couple of months, and like just like being able to do that and like it really validated the product. But on the other things that are more like art focused that we are building in house is a like NFT based projects that were not able to be done before, specifically with like taking external data and affecting those NFTs over time, whether that be for breeding processes or just like the NFT themselves shift over. So we've seen a lot of interest in art projects building on top of Waves. When we were at the Vault in Berlin, which was run by EigenLayer, which was a like hacker house of projects, we saw a really interesting technique as well from the Astral team. They've been working on like geolocation data for like the past 7, 8 years, and like how do you plug that into ecological benefits of like checking different areas. And so they were able to then extend this within ways to give you verifiable geolocation data. So you're able to now kind of build applications like the decentralized Uber that's been discussed since 2016 timeframes. How to build a DoorDash on chain, and how to build this in a way where you're not actually leaking the user's information on chain, but you're doing this off chain with some trusted, verifiable parties that can then prove that you are who you say you are. And so in doing this, Astra was able to build this verifiable geolocation data thing on top of Waves. So now we can do that. Another good example is like Rena, who's building a distributed TEE network. And so bringing like privacy on Ethereum to AVSs, I don't always want to have to submit my data on chain. I'm going to submit this via another route. Waves can pick that up and then submit the final output or something like that on chain. And you can verifiably prove not only was it run through Waves, but it was run through this TEE too. So we had multiple different parties here verifying that. And then the last good example I would bring up is Tria, who's building a solver for like solving AVSs and how we need to do something similar to like CalSwap. How do we like prove that these solvers are doing like the best quote they have, and they're not trying to like also like front run you behind the scenes? So those are like the top 3 cases I can pull up. There's a couple others, but I'll leave it at that.
Yeah, that's very exciting. We're getting into the last part of the podcast, and we've got GK on stage, who's got a couple of questions for you.
Hey Reece, congratulations on super interesting what you guys are building, and yeah, excited to see things built on top of EigenLayer. I think that they really disrupted infra in the last year. So what you guys are doing is very very interesting. So I was wondering, is there any, well, while you were describing the different components and how builders can leverage your technology, is there any use case that is using some sort of optimistic validation method using your stack?
We
Just
currently
curious.
don't have optimistic validation. If it's something that's like really interesting, like you have a thing, definitely talk with me after. I'm happy to work with you to see if that can fit on our roadmap, depending on if we can like generalize that to others as well. Right now, though, we do not. No.
All right. Yeah, I was just curious because all of these innovations in terms of validation and optimizing the the resources across the different layers of the infra are kind of novel. So yeah, that's totally fine. And also, I was wondering, in general, what's the revenue model for WAVs? I I suspect there is maybe some alignment with the data validation across the revenue sharing on the EigenLayer part, but maybe if you could just describe a little bit how essentially how the company sustains itself and the infra.
Yeah, right now we're purely just like VC based on our seed round. What the plan for going forward is there's like different ways we can do this because again we built Waves not for like others to like another info play. We did this entirely for our own products that we're building. So ideally we're sustainable with the products that we build, and like that is our revenue model in terms of like how does this actually go forward. Great, we've got 5 or 6 different products in house that we're looking to launch, and we want to like build those up. And if those are actually successful, then Waves is also indirectly successful there. Waves is currently not open source. All of the like tooling it's like MIT license. What we're going to have for Waves is we're going to have a not PSL license, but something similar. And then over the course of 2 years, that way that we're making sure to work with these different partners and having that for like, hey, if you're building on us, we want to have agreements with them, whether that be like a revenue share or something like that. So there's other options in different ways we can tailor it, where if you're, more like a larger entity, kind of like an EtherFi or something like that, or a Uniswap, someone that's larger, great, maybe you don't actually want to give up tokens, you'd rather just pay for us for consulting or something like that. So we can kind of be a dev shop for you if you have specific needs. So there's a lot of different ways that we can model that, but those are the 2 real main ways. Is hey, we can help you with consulting, we can help you with token share agreements. If your product is built on us, great, we can figure that out. And then the other option is hey, we just launch ours or some mix of those, which I think is what we're headed for. So being able to build up our applications, users use those. Now we take those fees and we kind of run our own AVSs and we dog food that way.
Amazing. All right. Thank you, Reece.
Right. Yes. Thank you, GK. And with that, we get to the end of the podcast. Thank you so much, Reece. That has been a pretty fast-paced, informative, really spot on. Really excited for Waves, actually. And with no intention to steal that revenue from being a dev shop yourself. Currently, if anybody wants to build on Waves and they do not have the capacity, Let's remind that dOrg is basically your Web3 dev shot, and we can help you build all of these projects, either milestone-based collaborations, team extensions, protocol partnerships. If you're having trouble hiring, that's a pain in the butt sometimes. We can get you access to our membership pool and get somebody onboarded in 72 hours. So huge value there. And yeah, if you need anything specifically, we can customize any solution for you, the listener, and you, Reece, if you need anything, you need help building WAVS or any other products in Layer, let us know.
So,
any last words that you'd like to say, Reece?
developers, if you're looking to build on WAVS and you're interested, WAVS.xyz, you can find that on the website. That'll bring you into the documentation. I myself have tutorials that I'm walking people through. I'll walk you through the entire code base, how this stuff works, and the documentation will walk you through a basic Bitcoin Oracle example in any language of your choice, realistically. So excited to see what people have questions of, as well as what you guys can think of building.
All right, super excited for this, Reece. Thank you very much. Have an excellent rest of the day, and we hope to have you back with your next product of Layer at the dOrg Hot Seat. Take care.
Thanks, guys.